So I had some questions on the review. I want to just talk about them for a minute, and I won't go through the whole problem. But I think with a little explanation, that would help. Then that'll kind of get us all jump-started on what to do. So here's a formula sheet. You can rip the staples out if you want. Just do that. Bless you, because it makes it easier to pass out. So one question was over number 33, which says a radio station claims the amount of advertising per hour of broadcast time has an average of 14 minutes and a standard deviation equal to 1.5 minutes. So that's my mu and sigma, right? That's my population mean and standard deviation. You listen to the radio station for 1 hour at a randomly selected time, so just during 1 hour during the day, 1 full hour, and carefully observe that the amount of advertising is equal to 15 minutes. So that's going to be our observation right there. So that's our x minus mu over sigma, right? So it's kind of casted in a weird way, the way this question is asked, but that's all it is. So it says an average of 14 minutes per hour, so that's why you have to listen for an hour to get your value of advertising time. So it would be 15 minus 14 over 1.5. Be the z-score for that one. The problem's written here. 43. So remember our z-score formula. You can go find it in your formula sheet. 43 says the state energy agency mailed questionnaires on energy conservation to 1,000 homeowners in the state capital. 500 questionnaires were returned. So half. Suppose an experiment consists of randomly selecting one of the returned questionnaires. All right, consider these three events. In terms of A, B, and C, describe a home that is constructed of brick and is less than or equal to 30 years old. So that's our Venn diagram notation. Right, so there's an and right here. So constructed of brick would be A, and is less than or equal to 32 years old, it would be not B. Because B says home is more than 30 years old. So that would be the intersection of A and not B. Because it's negating B, it's saying less than or equal to. So it would be A intersect not B. Would be the answer there for 43, 53, and 56. Let's look at a couple more. Okay. It has been stated that 0.2 of the general population donate their time and energy to working on community projects. So that's 20%, right? Suppose 15 people have been randomly sampled and asked if they donated their time and energy. Let X be the number of them that do donate their time and energy to community projects. Find the probability that more than 15 do donate their time and energy to community projects. So this is 6 plus 7 plus 8 plus 9. This is where we need to go read that chart where it has the cumulative, where it adds together in the binomial. I didn't ask you a specific question like that on the test, but that's what you would do there. So it would be basically the binomial formula for 6 out of 15 plus 7 out of 15 plus 8 out of 15 plus 9 out of 15 all the way up to 15 out of 15. And you add together all those probabilities. Your binomial formula is right there, number 17. But we'd have to do it for each one, so really you'd have to look at the chart to answer that question, which I haven't given you that on the test, but I'm not asking you a question that way. But that's what you would do there, right? So that would be a binomial formula. With 0.2 being P, so what would Q be in that formula? 0.8, right? The complement, right? The opposite. So if 20% have success, that means 80% have failure. 56, suppose the random variable x has a normal distribution with mu and sigma. Find x naught such that 10% of the values of x are less than x naught. So that's basically the 10th percentile, right? That's where the tail on the left-hand side has 0.1 and then 0.9 above it, right? Which is really 0.4 at the at the midway. So this is how you'd answer that question, right? So we want x naught such that 10% of the values of x are less than x naught. So this is 0.1. That's 0. So what's my area right here? 0.4. So I would go find the z value that corresponds to 0.4 in the chart. And that would be the answer there. But it would definitely be, what's the sign going to be? Oh, that should be z. Because it says standard normal. But what's the sign of this thing going to be? Negative. It's going to be the negative z value. And you do have your chart and your formula sheets. We go look at it. It's the second to last thing. So the one that's closest to 0.4 is 1.28, between 1.28 and 1.29. So it would be negative, and I would accept either one in that case, because it's not exactly 0.4. Everybody see what's going on there? So I would go for the z-score that corresponds to 0.4, bless you, which is 1.28, essentially. It's closer to 1.28 than 1.29. Right. Right. So I found z, so I need to plug it in and solve for x here. Yeah, I'm getting it from the z-score chart, right? Because it says it's got a normal distribution. So the z value that corresponds to this, let's just say it's negative 1.28. So now I need to go find the x value that corresponds to z being negative 1.28. So I would solve the equation equals x minus mu, which is 470, divided by sigma, which is 50. So I would solve that for x. I'm multiplying both sides by 50 and then adding 470. Because it's basically asking what's the 10th percentile, right? What has 10% below it and essentially 90% above it. But our chart tells us from 0 out. We good on that? You guys understand what's going on there? Right. Okay. That's the stuff I had questions about on this. Okay. So, just to point out a few things in your study guide or in your formula sheet. What's that? The fourth page has your type 1 and type 2 errors defined. The sixth page has your common z values, all right, for one and two-tailed tests. If you're finding a confidence interval, that's a two-tailed test, right, or similar to a two-tailed. That's the values of z that you use. Okay? Remember our p-value? If the p-value is less than alpha, what do? Reject H0. If p-value is greater than alpha, then we fail to reject H0. Okay? And then on the first couple pages is your union, intersection, additive role, complements, that type of stuff. Expected value. uniform distribution, and so on. Okay? So pencils and calculators only. Once you're done, give it to me. I should have it graded by the end of the day. And then I'll post your grade in my MATLAB, and then I'll post it on Banner as well. All right? Does everybody know how to check their grade in Banner? Yeah? No? I can show you how to do that. And good luck. Show as much work as possible. Boom.